Hello my friends and welcome back to the You Can Do TV channel. SIMEC's Azizico plant in Mexico operates a state-of-the-art facility for special bar quality SBQ steel production, starting with a 90-ton electric arc furnace EAF optimized for energy efficiency and low emissions. Fume and water treatment are managed by Daniele Environment Systems, ensuring environmental compliance. Steel refining includes a twin ladle furnace with dual ladle cars and a twin tank, single cover vacuum degasser equipped with a mechanical dry pump, ensuring low hydrogen and nitrogen levels. Continuous casting is performed through a 3-strand caster for round blooms, 300, 450, 500 millimeters, utilizing Daniele power molds with electromagnetic stirrers in mold and final zones for structural homogeneity. The hot-rolled products are processed through a walking beam reheating furnace, followed by a breakdown mill and a 6-stand SHS Plus pre-finishing mill. The Q3 intelligence system from Daniele Automation ensures real-time digital monitoring and process control. Tight dimensional tolerances down to 1/8 DIN A are achieved with the DSD drawer 4-row block. Products then pass through a 78 by 16 meters walking beam cooling bed and are cut to length using automatic saws. Online non-destructive testing ensures product integrity. The high-speed wire rod line features 2-pass pre-finishing and 10-pass finishing blocks, operating at up to 115 meters per second. Cooling is controlled via fan-assisted conveyors. Coils are formed in a pit with an RRT rotary reforming tube and easy down system, then handled by a Sunco 5 vertical trestle conveyor and compacting tying station. Final SBQ products include wire rod sizes from 5.5 millimeters 7/30 seconds to 25.4 millimeters 1. At JW Aluminum, the aluminum rolling process is a continuous operation conducted 24/7 across 4 U.S. plants. It begins with blending prime aluminum ingots and recycled scrap to form the correct alloy. These materials are melted in large furnaces at over 1,000 degrees Celsius, where furnace operators maintain cleanliness, optimize metal recovery, and ensure the alloy meets required chemistry. Molten aluminum is transferred into casting machines through filters, solidifying into large coils via water-cooled rolls. These cast coils, once cooled, are processed in the cold mill where sheet thickness gauge is reduced. Coils are then annealed in high-temperature ovens to soften the metal, allowing for further thinning. Subsequent cold and foil mill operations reduce thickness further, with operators controlling tension, pressure, and speed to maintain product quality and prevent defects. After final gauge is achieved, coils undergo slitting to meet customer width requirements. Lubricants are applied via electromagnetic coating to suit downstream press applications. Coils are cut, tested for tensile strength, elongation, and quality, then packaged per customer specifications. Labeled and stored systematically, each product's journey is traceable. The final product, aluminum used in consumer goods like pans, is the result of precise engineering, consistent quality control, and pride in craftsmanship. Lochaber Smelter in Scotland, with over 100 years of aluminium production, remains a symbol of industrial excellence. Originally developed in the 1920s by British Aluminium, It relied on a vast hydroelectric network spanning 90 miles, an engineering feat constructed manually by over 2,000 workers. The facility processes alumina from bauxite through electrolysis, using high electrical currents to produce molten aluminium. Carbon anodes are consumed and replaced regularly while emissions are carefully monitored. The molten metal is cast into billets or ingots, with alloys added as required. Recent upgrades include new turbines and biomass systems for sustainable power. Liberty's plan to build an adjacent auto parts factory will increase aluminium value and cut environmental costs by producing finished goods directly from molten metal, enhancing both efficiency and local employment opportunities. Hot rolling is a key industrial process used by Hasslich to shape steel at high temperatures, typically above 1,100 degrees Celsius. The process begins by heating steel billets or blooms in a reheating furnace until they reach the desired rolling temperature. Once heated, the material is passed through a series of rolling stands, where it is progressively reduced in thickness and shaped into the required cross-section. Hasslich uses advanced hot rolling mills equipped with automated control systems to ensure dimensional precision and consistent surface quality. The process improves the steel's mechanical properties by refining its grain structure. After rolling, the steel is cooled under controlled conditions to maintain structural integrity. Depending on the application, additional processes such as cutting, straightening, or coiling are performed. Hot rolling at Hasslich ensures high production efficiency, material strength, and surface finish, meeting the stringent demands of automotive, machinery, and construction industries. At Aceros Angeletti SA, the hot rolling process for bars, billets, and flats begins with the extraction of steel ingots from a deep pit furnace using a clamp-type overhead crane. These ingots are then transferred to an approach table, where they await entry into the primary rolling train. The first rolling stage is performed by a reversible duo rolling mill, powered by two 3,000 HP motors. This equipment reduces the ingot into a square billet with a cross-section of 220 by 220 millimeters. After initial shaping, the billet moves to the exit table, where it is cut to length using oxy-fuel torches. The cut sections are stacked on ripiolite beds and then charged into a push-type reheating furnace to bring them back to optimal rolling temperature. Once reheated, billets exit onto a discharge table and are guided toward a second reversible duo mill for further reduction to the final dimensions. Following this, a cutting saw trims the product to the desired length. The hot bars are then conveyed through a cooling and evacuation rack, allowing them to air-cool uniformly. After cooling, the bars pass through automated straightening machines for alignment, followed by surface conditioning and ultrasonic testing to check for internal or surface defects. The final product, precisely rolled, inspected steel bars or flats, is prepared for dispatch, stacked and labeled according to customer specifications. This streamlined process ensures high-quality results, meeting rigorous industry standards for strength, geometry, and finish. This process showcases the precision forging of stainless steel flanges using closed die drop forging technology. Starting with certified super duplex stainless steel, NORSOK approved for demanding offshore applications. The billet is heated and shaped under extreme pressure using custom dies. The closed die forging method ensures repeatable dimensional accuracy and superior grain structure alignment, critical for mechanical integrity. A finishing blow further refines the flange geometry, followed by the use of a clipping tool to remove excess flash material from the forging. The result is a highly durable, corrosion-resistant forged flange ready for subsequent machining or quality inspection. This specialist forging process combines strength, consistency, and compliance with rigorous industrial standards for high-performance applications. A hot-rolled 150 mm plate rolling machine is engineered to bend thick steel plates into cylindrical or conical shapes. It uses high-pressure hydraulic rollers to gradually form the 150 mm thick hot-rolled steel plate. Precision control systems ensure uniform curvature, making the machine ideal for heavy-duty applications in pressure vessels, wind towers, and large industrial components. Fire extinguisher cylinders are manufactured through a precise industrial process to ensure durability and safety. It begins with selecting high-quality materials, typically steel or aluminum, for the cylinder body. Metal sheets are cut into circular blanks, which are then cold-drawn or deep-drawn using hydraulic presses to form a seamless cylindrical shape. This process involves multiple stages of pressing and stretching to achieve the desired thickness and strength. Next, the cylinder is trimmed and necked at the top to create a threaded opening for the valve assembly. The interior is cleaned to remove impurities, often through chemical washing or blasting. For added corrosion resistance, steel cylinders may undergo phosphate coating or galvanization, while aluminum ones are anodized. The cylinder is then pressure tested to ensure it can withstand high internal pressures, typically up to 1.5 times the operating pressure. After passing tests, the exterior is painted or powder coated, often in red, for visibility and protection. It's filled with an extinguishing agent, e.g., dry powder, CO2, or foam, and sealed for distribution. Finally, the valve, nozzle, and other fittings are assembled, and the cylinder is labeled with safety instructions and specifications. Each step adheres to strict safety standards and pack for delivery. Bertan Máquinas para Cerâmica is a Brazilian manufacturer renowned for its high-performance machinery tailored to the ceramic industry. Their equipment line covers every step of clay processing, from feeding to extrusion, delivering reliability, energy efficiency, and safety in compliance with modern standards. Each machine is developed with a focus on high productivity, low maintenance cost, and user safety. The process begins with the caixão alimentador, a clay feeder designed to provide consistent material flow. It includes a robust steel frame, reinforced U-profile conveyor belts, and a geared reducer system with multiple speed levels. Rotary knives break down clay clumps, driven by two independent motors. The feeder's storage can be expanded using a Bertan metal silo. Next is the disintegrador, DB500, DB600, used to break up dry clay lumps and stones using dual rollers, one smooth, the other equipped with high-speed knives. Its structure incorporates oversized steel bearings and spring-loaded components for safe passage of foreign objects. The homogenizador, HB600 HB720, follows, fragmenting clay via hammer shoes and forcing it through a sieve for granulation. This unit features a welded steel frame, alloy steel gears, and reinforced bearings, providing outputs from 12 to 30 tons per hour. Bertan's misturadores, MB100, MB3300, are responsible for mixing different clay types. The dual shaft mixers have cutting blades, easy maintenance parts, and a pneumatic clutch. They ensure homogeneity and efficient blending, vital for high-quality ceramic products. The laminadors LB500, LB800 refine the clay by removing stones and distributing moisture uniformly. Built with cast iron frames and oversized spherical roller bearings, the dual roller laminators feature replaceable jackets and optional pneumatic scrapers. An optional grinding machine is available for jacket reconditioning. For final shaping, Bertan offers the Extrusora Evacuo, EB295 EB430, and Extrusora Monoblocco Evacuo, EMB 350/450. These vacuum extruders remove air, compact the clay, and form it into blocks or tile rods. Their robust steel construction, oversized gearboxes, dual-axis mixers, and vacuum chambers ensure superior product density and surface quality. The Monoblocco model improves air evacuation with a full-length vacuum chamber, optimizing extrusion even at low clay moisture levels. Bertan's legacy, dating back to 1970, continues through modernized facilities and a skilled workforce. Their equipment is trusted across Brazil for its durability, ease of maintenance, and optimized energy consumption, delivering precision and performance from clay preparation to extrusion. Bridgestone's earth-mover wheel maintenance process ensures durability and safety in extreme mining environments. The procedure begins with disassembly, cleaning, and surface blasting. Critical areas are inspected using Magnaflux and ultrasonic testing to detect cracks or fatigue. If repairable, damaged sections are removed by plasma cutting, replaced, and welded using submerged arc welding. Stress is relieved through shot peening, and corrosion is prevented with zinc treatment. This technical process extends wheel life, reduces cost per hour, and mitigates the risk of failure in high-pressure mining operations. The Burkhardt plus Weber MCT 1000 is a high-performance multitasking machining center engineered for demanding applications involving milling, drilling, and turning operations in a single setup. Designed for flexibility and precision, it features an NC-controlled tilting spindle and high-strength turning tool holders, enabling complex multi-axis machining. At the core of its design is a high-speed torque table capable of horizontal and vertical turning, minimizing the need for secondary lathes and reducing part handling. This integration significantly enhances production efficiency and ensures dimensional consistency. Ideal for industries requiring precision and throughput, the MCT 1000 supports optimized material flow, reduced work in progress, and lean inventory control. Its multitasking capabilities allow for the consolidation of manufacturing processes, leading to improved cash flow management and return on investment. Kingsbury's integration of the MCT 1000 provides manufacturers with a robust, high-output solution for complex component machining in aerospace, automotive, and heavy industrial applications. The Okuma Genos L300EMI is a compact, high-performance multitasking CNC lathe designed for precision, flexibility, and affordability. Built on a rigid cast iron base, it offers exceptional thermal stability for maintaining accuracy during extended operation. This machine features a powerful 20 HPA28 spindle, Y-axis functionality, and high-speed milling capability, making it ideal for complex part geometries. Equipped with a 12-station live turret, automatic parts catcher, chip conveyor, and Okuma's intuitive OSP control system, the Genos L300E supports efficient multitasking operations. It handles a variety of workpieces, from chucking to bar-fed components, within a compact footprint of just 72 square feet. Its robust build and integrated features make it an ideal solution for manufacturers seeking reliable performance and cost-effective versatility in modern machining environments. The Okuma Multus U 4000 5-axis lathe demonstrates high-performance gear milling with advanced turn mill capabilities. Using Invo milling technology, it efficiently machines complex gear geometries such as straight and helical gears. Gear sizes include U140x80 with Module 8 at 0 degrees and Module 4 at 15 degrees, ensuring versatility across profiles. Additionally, it handles herringbone pitch milling up to U208 by 260 Module 8. The Multus U4000 enables precise multi-gear shaft production in a single setup, reducing cycle times and enhancing machining flexibility. Thompson's subcontract friction welding delivers advanced manufacturing for a wide range of industrial components. With proven process innovation, Thompson offers direct drive welding solutions using equipment rated from 4 to 300 tons. Systems are available in both single and double-ended arrangements, with flexible load and unload configurations. Internal and external flash removal ensures clean welds, while precise weld orientation capabilities allow for complex component geometries. This technology supports critical applications across sectors where strength, accuracy, and repeatability are essential. The robot drive joinery machine, developed by Hundiger, represents a pinnacle of versatility, performance, and flexibility, drawing on the expertise gained from over 6,000 delivered machines. This advanced system is designed to meet the diverse needs of timber construction companies, offering a modular and customizable solution that can be tailored to specific tasks through in-depth consultation with Hundiger's experienced engineers. Equipped with a 6-axis robot unit paired with a 5-axis saw/slot/marking unit, the robot drive stands out as a unique solution in the market, capable of delivering high-precision processing for a wide range of applications. Its compact dimensions and modular design ensure maximum flexibility, allowing for nearly unlimited processing possibilities. Additionally, the machine can be retrofitted on-site to adapt to evolving requirements, making it a future-proof investment for timber construction businesses. The robot drive excels in processing beams and columns, accommodating cross-sections from 20 by 60 millimeters up to 300 by 1,300 millimeters, depending on the model, robot drive 450, 650, or 1300. The 6-axis robot unit, with a standard 12 kilowatt spindle, upgradable to 29 kilowatts with speeds up to 15,000 revolutions per minute, enables precise trimming, grooving, drilling, milling, slotting, and marking. The 5-axis saw/slot/marking unit, featuring an 800 millimeters flangeless saw blade, supports complex cuts such as chop, miter, and compound cuts, as well as bird's mouths, ridge laps, and scarf joints. This combination ensures high-quality surfaces and accurate processing, even for large laminated girders and cross-laminated timber, CLT. The machine's ability to process all 6 sides of a component in a single pass eliminates the need for repositioning, enhancing efficiency. For short components, the robot drive offers a small parts conveyor belt option, enabling efficient handling and processing of smaller timber pieces. The conveyor system automates the infeed and outfeed of components, with a maximum timber length of 10 meters, extendable as needed. The system's servo-driven feed/clamping device ensures precise positioning with an accuracy of plus or minus 0.5 millimeters. This setup is ideal for high-throughput production of small components, such as those used in timber framing or modular construction, minimizing manual intervention and maximizing productivity. The automatic infeed buffer with stainless steel slat band chains allows operators to load multiple pieces simultaneously, further streamlining operations. The robot drive is adept at producing short dovetail components, leveraging its 6-axis robot unit and automated tool changer with 16 tool slots. Dovetail milling cutters, combined with the 5-axis milling unit, enable precise creation of dovetail joints at any angle and inclination. The machine's Cambium software optimizes tool selection and processing cycles, ensuring high-quality finishes suitable for visible timber frameworks, such as those in half-timber construction. This capability is particularly valuable for producing compact, structurally sound components with minimal waste, catering to both aesthetic and functional requirements. Dovetail rafters with tenon holes are efficiently crafted using the robot drive's advanced milling and drilling capabilities. The 6-axis robot unit, equipped with dovetail mills and drill bits, can produce conical dovetail joints and precise tenon holes in a single pass. The 5-axis unit's 360 degrees rotation and 180 degrees tilt allow for complex geometries such as rising bird's mouths and oblique drillings without requiring part rotation. This ensures accurate alignment and high-quality surfaces, critical for rafters and timber frame construction. The machine's ability to handle cross-sections up to 300 by 1,300 millimeters makes it suitable for large-scale rafter production. The robot drive is optimized for producing hip and ridge beam rafters, which require precise cuts and joints for structural integrity. The 5-axis saw/slot/marking unit performs valley cuts, ridge cuts, and eaves formwork notches with millimeter accuracy. The 800 mm flangeless saw blade supports slotting and segmenting, while the 6-axis robot unit handles additional milling or drilling tasks, such as creating recesses or profiles. This combination allows for rapid, high-quality production of complex rafter geometries, ensuring seamless integration into roof structures. The machine's modular design allows for retrofitting additional units to meet specific project demands. Ornamental rafters, often used in visible timber frameworks, benefit from the robot drive's ability to produce high-quality, visually appealing surfaces. The 6-axis robot unit, with its variable speed spindle 0 to 15,000 revolutions per minute, supports intricate milling operations, such as decorative profiles and cloggings, using cylindrical or dovetail mills. The Cambium software optimizes tool paths to achieve smooth, polished finishes suitable for aesthetic applications. The machine's precision ensures that ornamental rafters meet both structural and decorative requirements, making it ideal for restoration projects or high-end carpentry. Rafters with corbel profiles are crafted with precision using the robot drive's 5-axis milling unit, which supports the creation of complex profiles and bird's mouths. The unit's ability to tilt 180 degrees and rotate 360 degrees allows for accurate milling of corbel geometries at any angle. The 6-axis robot unit complements this by performing additional tasks such as drilling or slotting to complete the rafter in a single pass. This capability is particularly useful for custom timber constructions where core-built profiles enhance both structural support and visual appeal. Rafters with core-built profiles are crafted with precision using the Robot Drive's 5-axis milling unit, which supports the creation of complex profiles and bird's mouths. The unit's ability to tilt 180 degrees and rotate 360 degrees allows for accurate milling of corbel geometries at any angle. The 6-axis robot unit complements this by performing additional tasks such as drilling or slotting to complete the rafter in a single pass. This capability is particularly useful for custom timber constructions, where core-built profiles enhance both structural support and visual appeal. The Robot Drive efficiently produces bottom plates with stud slots and dado grooves, critical components in timber framing. The 6-axis robot unit, equipped with a slot cutter, can create precise slots up to 300 millimeters deep from all 6 sides of the timber. The 5-axis saw/slot unit complements this by producing dado grooves and other recesses with high accuracy. The machine's automated tool changer ensures rapid switching between slotting and milling tools, while the Cambium software optimizes processing sequences to minimize setup times, enhancing productivity for large-scale production. Notched scarf joints, commonly used in beam construction, are primarily created using the Robot Drive's 5-axis saw unit, which features an 800 mm flangeless saw blade for precise cutting. The unit's 360 degrees rotation and 180 degrees tilt enable complex scarf joint geometries, ensuring tight fits and structural integrity. For larger recesses, the saw unit can fully saw rather than mill, reducing processing time and scrap size. The 6-axis robot unit can perform supplementary milling or drilling to refine the joint, making the Robot Drive ideal for producing durable, high-quality scarf joints. The Robot Drive supports the creation of slotted knife plate connections, which require precise slotting and drilling. The 6-axis robot unit, equipped with a slot cutter, produces slots up to 300 millimeters deep at any angle, while optional horizontal drill units, up to 2, with a maximum depth of 525 millimeters, handle rafter nail holes or purlin doubling. The machine's ability to process all 6 sides without repositioning ensures accurate alignment of slots and holes, critical for secure knife plate connections. The automated tool changer enhances efficiency by minimizing tool changeover times. Housed double tenon components are produced with high precision using the Robot Drive's 6-axis robot unit, which employs end mills and dovetail mills to create centered tenons. The machine's servo-driven feed system ensures exact positioning, while the 5-axis milling unit supports synchronous processing on multiple sides, reducing production time. The Cambium software automatically selects optimal tools and speeds, ensuring the tenons are accurately housed within the component, ideal for robust timber frame joints. This capability is particularly valuable for half timber construction, requiring strong, hidden connections. The Robot Drive excels in producing housed dovetail tenons and mortises, leveraging its 5-axis milling unit for conical dovetail joints and the 6-axis robot unit for precise mortise milling. The combination of dovetail mills and HSK 63E tool holders allows for rapid tool changes, enabling the machine to create complex joint geometries in a single pass. The 360 degrees rotation and 180 degrees tilt of the 5-axis unit ensure accurate angles and inclinations, making it suitable for high-quality, visually appealing joints in timber framing and restoration projects. Frontal boring with long drill bits and pilot milling is efficiently handled by the robot drive's optional horizontal drill units, capable of drilling up to 525 mm deep without tool changes. The 6-axis robot unit performs pilot milling to ensure precise hole alignment using end mills or cylindrical mills. The swiveling deep hole drilling unit, rotatable 360 degrees, can process all 4 sides of the component, making it ideal for applications like rafter nail drilling or dowel insertion. This combination ensures high accuracy and efficiency for complex boring tasks. The robot drive's integrated inkjet and marking systems enable precise labeling and marking of components. The robot arm's inkjet system applies text, graphics, or barcodes in various colors, while the 5-axis saw/slot unit's marking device can label rafter divisions or post positions on 3 sides without tool changes. The Cambium software manages label data, ensuring accurate placement of details like part numbers, cut grades, or roof side information. This feature enhances traceability and assembly efficiency in timber construction projects. Block log with quarter blade connection and window recess with groove milling. In log and chalet construction, the robot drive produces block logs with quarter blade connections and window recesses. The 6-axis robot unit, equipped with profile milling cutters tailored to customer specifications, creates precise quarter blade joints. The vertical slot cutter handles window cutouts, while groove milling is performed with high accuracy using the 5-axis milling unit. The machine's ability to process round timber and log profiles without setup changes ensures efficient production of complex log components, ideal for chalet-style buildings. Cling scribing connections, used in log construction, are crafted using the robot drive's 6-axis robot unit with specialized milling tools. The unit's 360 degrees approach capability ensures precise scribing on all 6 sides of the log, eliminating the need for repositioning. The Cambium software optimizes tool paths for smooth, high-quality surfaces, critical for tight-fitting cling connections. This feature supports the production of robust, aesthetically pleasing log structures with minimal waste. The robot drive produces Tyrolean lock connections and frogs for block logs, using its 6-axis robot unit and vertical slot cutter. The Tyrolean lock, a traditional log joint, is created with precise milling and slotting, while the frog, a groove for sealing, is milled using cylindrical or profile mills. The machine's high-performance spindle, up to 29 kilowatts, ensures rapid processing, while the automated tool changer minimizes downtime, making it ideal for high-throughput log home production. Tyrolean lock cuts are efficiently executed using the robot drive's 5-axis saw unit, featuring an 800 mm flangeless blade. The unit's 360 degrees rotation and 180 degrees tilt allow for precise sawing of lock geometries at any angle, ensuring tight fits and high-quality finishes. The interplay between the saw unit and the 6-axis robot unit enables rapid production of Tyrolean locks, reducing processing time and enhancing productivity for log construction applications. The robot drive, in conjunction with the Hundiger SPM 2-speed panel machine, processes panel components with saw cuts and ribs for wall, floor, or roof elements. The 5-axis saw unit handles cutting and notching, while the 6-axis robot unit mills ribs for structural reinforcement. The SPM2 supports panel thicknesses from 5 mm to 120 mm, processing materials like solid wood, glulam, and CLT with high precision. This setup ensures efficient production of pre-finished panels with integrated ribs. For panel components with openings, recesses, ribs, and corner milling, the robot drive's 6-axis robot unit and 5-axis milling unit work in tandem. The robot unit mills precise openings and recesses, while the saw unit handles corner milling and notching. The machine's ability to process CLT and sandwich elements with millimeter accuracy ensures high-quality finishes for complex panel geometries. The automated in-feed and out-feed systems enhance throughput, making it ideal for large-scale panel production. The Hundiger robot drive is a transformative joinery machine, offering unparalleled flexibility and precision for timber construction. Its 6-axis robot unit, paired with a 5-axis saw/slot/marking unit, supports a wide range of applications, from beam and column processing to intricate log and panel components. With its modular design, customizable options, and retrofitting capabilities, the robot drive adapts to evolving needs, ensuring long-term value for carpentry, timber framing, log construction, and CLT production. The integration of advanced Cambium software and automated tool changers further enhances efficiency, making the robot drive a cornerstone of modern timber processing. Lifting a crankshaft requires careful planning and proper equipment. As one of the engine's heaviest components, it demands sufficient manpower and lifting tools. The crankshaft is carefully hoisted from the bed plate using overhead cranes or lifting beams. Once clear, it is lowered into a specially designed transport cradle. This cradle supports the crankshaft securely during handling and transport, ensuring both safety and efficiency throughout the procedure. The assembly process of a large DN1400 welded ball valve inside an industrial workshop. The ball valve, used to control the flow of liquids or gases, features a rotating ball with a central bore. It is lifted using a chain hoist and crane, indicating the component's significant weight. These valves are widely used in various industrial and civil applications, including water supply systems, HVAC, and process pipelines. The KIROW Slag Taurus is a heavy-duty slag pot carrier designed for continuous use in steelworks. Built on a reinforced welded steel frame, it integrates a hydro-mechanical drive system powered by high-performance engines from manufacturers like Cummins or Caterpillar. Its articulated steering allows up to 90 degrees turns, ideal for confined areas. The braking system includes 3 independent hydraulic circuits, ensuring maximum safety. A heat-protected internal support cylinder secures the slag pot during transport and tipping. With options for conventional or coupling rod tipping systems, the Slag Taurus adapts to varied cycle times. Centralized control via the KIROW Integrated Safety System KISS enhances monitoring safety and reliability. Forward piling, also known as cast in situ piling, is a deep foundation technique used to support heavy loads from high-rise structures or in poor soil conditions. Unlike displacement piles that are hammered into the ground, board piles are formed by removing soil and casting concrete on site. This method produces low noise and vibration, making it suitable for urban and sensitive environments. The process begins with precise site marking and casing installation to prevent soil collapse. Drilling is performed using augers or buckets depending on soil hardness. Bentonite slurry is used to stabilize the borehole by exerting hydrostatic pressure, and its properties, such as viscosity, density, and sand content, are constantly monitored. Once the required depth is reached, the borehole is cleaned and the steel reinforcement cage is inserted. Concreting is done using trimmy pipes to ensure continuous concrete placement from the bottom up. After concreting, the casing is carefully extracted. Quality control includes slump testing for workability, concrete cube tests for compressive strength, and several integrity tests such as PIT, PDA, sonic logging, and caliper tests to confirm load-bearing capacity and pile continuity. Board piles are also used in forming retaining structures like contiguous or secant pile walls and diaphragm walls for deep excavations. In 2015, Arsenault, Wilson & Cole completed North America's longest direct pipe installation using advanced trenchless tunneling. A 48-inch steel pipeline was installed beneath the Hurricane Levee rail switchyard and the Sabine-Neches Canal. Due to weak clay soil, conventional horizontal directional drilling was ruled out after hydraulic fracture analysis. The team employed the Heron Connect direct pipe system, combining a micro-tunneling boring machine, MTBM, and a 750-ton hydraulic pipe thruster. This allowed simultaneous boring and pipe installation while controlling soil pressure and minimizing surface disturbance. The MTBM used bentonite slurry for lubrication and spoil removal. Steering control ensured precise alignment through constrained spaces. Additional pipe segments were welded in line during drilling. Construction was confined to a narrow corridor between a highway and residential area, requiring careful logistical planning. The system's ability to pause without destabilizing the bore path enabled flexible execution. The Belgian Tunnel project in Switzerland showcases advanced full mechanized tunneling with a focus on efficiency and precision. A tunnel boring machine, TBM, performs full round excavation while simultaneously installing an 80 centimeters thick in situ concrete lining directly behind the cutter head. This inlining process includes full waterproofing and hot melt application, ensuring long-term durability. Heavy reinforcement is installed mechanically, followed by precision-built mobile formwork designed by Marty. Concrete is pumped efficiently, and formwork is advanced in sync with the excavation. Critical utility supply lines are relocated from the crown area, allowing unimpeded progress. Construction continues safely beneath existing infrastructure, including a bridge. Quality control measures are conducted at every stage to verify the integrity of structural elements. The project benefits from seamless coordination among 3 expert firms operating under one unified system, achieving high performance and reduced construction time. In this road construction phase, workers operate specialized machinery to apply a single-layer surface treatment known as monocapa. This process involves spreading a dark paving material onto a prepared roadway. The material may include permeable asphalt such as Flexipav, composed of recycled tires and high-strength aggregate. Flexipav allows water to percolate through at rates exceeding 11,000 liters per hour, helping mitigate surface runoff and flooding. The hot asphalt mixture, consisting of crushed andesite stone bound with bitumen, is applied using a mechanical paver. This machine ensures a consistent application of material, maintaining the required thickness and surface profile. Following this, a chip spreader evenly distributes coarse aggregate across the hot surface to improve texture and traction. Personal protective equipment is strictly used on site. All workers wear high-visibility orange safety uniforms, helmets, and gloves in accordance with construction safety standards. During finishing, workers use large metal rakes to manually adjust and refine the distribution of stone, particularly along the road edges. Raking along the perimeter is critical to ensure proper bonding at the edges and a clean visual boundary. This attention to detail also prevents future edge deterioration caused by water ingress or traffic wear. Supervisors monitor the spreading and raking process, verifying uniform coverage and the operation of both asphalt and aggregate equipment. After raking, compactors pass over the surface to embed the stone and achieve the required compaction density. The monocappa system provides an efficient, durable, and environmentally conscious surface, ideal for both new road construction and resurfacing projects where permeability and fast application are priorities. The construction of Dragon Herald Fairhair, a 35-meter-long Viking dragon ship, exemplifies the traditional clinker-built shipbuilding technique, combined with precise craftsmanship and structural understanding. The process begins with laying the keel and attaching the stem and stern using curved transition timbers called lots. Templates and angle boards ensure correct alignment during assembly. Strakes, planks forming the hull, are bent and overlapped, then secured using iron nails driven from the outside and locked with roves inside. Each nail is hammered over 100 times, forming tight joints. Between every overlapping plank, tar and hemp are applied to provide a watertight seal. This method is known for creating flexible yet durable hulls capable of withstanding rough seas. Frames, ribs, are installed after several strakes are in place, shaped to match the hull curvature precisely. Internal longitudinal reinforcements called stringers are mounted to distribute stress along the hull. These are scarf-jointed and nailed with wooden dowels, reinforced with wedges. Critical structural components such as standing knees and cross braces are custom fit, clamped, and secured to stabilize the ship's form. Wood carvers create the ornamental dragon head from oak roots, carved in multiple sections for structural integrity. Final adjustments ensure full freeboard and balance. Over 20 months, a team of skilled craftsmen employed centuries-old Norwegian shipbuilding practices, creating a historically accurate and seaworthy vessel capable of accommodating a 100-man crew. The M25 manual cable stripper is a compact and highly efficient tool designed for removing insulation from a wide range of electrical cables and wires. Built with fixed rollers and a durable cutting blade, the machine is engineered for both ease of use and high performance. Its fully disassemblable frame allows for convenient maintenance and portability. One of its key features is the ability to connect a power drill in place of the standard hand crank, offering the flexibility to switch between manual and semi-automatic operation depending on workload. This model is particularly effective for stripping SIP, self-supporting insulated wire, making it ideal for utility and recycling applications. In operation, the cable is fed through a grooved lower roller designed with a conical recess and gripping marks to maintain traction. As the cable moves forward, a precision-mounted knife on the upper roller scores and cuts the insulation. The depth of the cut can be easily adjusted using a plastic adjustment knob located at the top of the unit, which raises or lowers the upper roller to accommodate different wire thicknesses. Two guide plates with multiple entry holes help align the cable correctly, ensuring consistent results and minimizing the risk of improper cuts. With a processing capacity of over 300 kilograms per 8-hour shift, the M25 provides industrial-level performance in a compact format. It handles cable diameters from 1 mm to 30 mm and weighs only 5.5 kilograms, making it easy to carry and relocate. The machine dimensions are 15 x 15 x 31 centimeters, and it includes one replaceable cutting knife. The complete package contains the stripping machine, user manual, hand crank, and a shaft for drill attachment. Reliable, lightweight, and versatile, the M25 is an excellent choice for professionals seeking efficient wire recycling or stripping solutions.